Hello students, once again welcome you to GK's maths classes. Today we are going to do few more problems in Maxima Minima, that is word problems. This is the part 5 video of Maxima Minima where we are solving word problems. Okay, so the introduction to Maxima Minima I have put it in part 1, which I will put in the description box. In case you want to refer, you can always go through it. Okay, so let's not waste any more time. I will not be going to the details of the concept of Maxima Minima. We will only going to solve the problems. Okay, so let's start with the first question. It's a very important question. If the sum of the length of the hypotenuse, of a side of a right angle triangle is given. Okay, so what is given here? The sum of the length of the hypotenuse, that is hypotenuse side, and one more side, whichever side, there are three sides, so one is hypotenuse, other one is the other side, and sum of them is given. Now you have to show that the area of the triangle is maximum when the angle between them is pi by 3. When I say between them, it means angle between the hypotenuse and the side that you are considering to add. Okay, so let's go to the problem. So first of all, let me take a right angle triangle. This is a right angled triangle, and I will name it as this is X, this is Y, and this is H. Those two sides are X and Y, and the hypotenuse is H. Now what is given? Sum of the length of the hypotenuse. Sum of the length of the hypotenuse. So I will take S to be sum of the length of the hypotenuse and a side, whichever side. I can choose X or I can choose Y. I prefer to choose Y. So this is given. So here S is a constant. So S is a constant. Now what I should do? I should maximize the area of the triangle. So what is area of a triangle formula? Area of a triangle is half base into height. Half base into height. Half X, Y. Now there are two variables involving X and Y. I have to change it to a single variable. So what I will do, I am going to use Pythagoras theorem, and I am going to change X. I will not change Y because my S is given in terms of Y, so I don't want to miss out that Y. So S is not involving X. I want to get rid of the X. Okay. So what is area? Half Y into root of H square minus Y square. Using Pythagoras theorem, I got this. But still there are two variables. What are they? Y and H. Remember, I have to bring it to a single variable. So now what I will do, this is half Y into root of, what is H? H is S minus Y the whole square minus Y square. S minus Y the whole square minus Y square. So area equal to half Y into root of S square minus 2SY plus Y square minus Y square gets cancelled. Now remember what we did in previous videos. When there is a square root, I want to get rid of it. How do I get rid of that square root? So I square it and I will call it as K. So what is K equal to? So my K equal to 1 by 4 Y square, 1 by 4 Y square into S square minus 2SY. So I am now comfortable. My square root is not there. It's easy for me to differentiate. So before differentiating, to avoid the product rule, I open the bracket. So what do you get? S square Y square minus 2SY cube. Okay. So now I am going to differentiate. dk by dy. First differentiation, which is 1 by 4 into S square is a constant. Differentiation of Y square will be 2Y minus 2S is a constant. Differentiation of Y cube will be 3Y square. Now I am going to equate it to 0 to find the critical point. dk by dy equal to 0. So what do you get? 2S square Y equal to 6sy square. Now clearly S and S cancels, 2 and 6 cancels. So you're left with S is equal to 3y. S is equal to 3y. Let it be there. Now second derivative. Second derivative I am going to establish whether the area is maxima or not. So d square k by dy square. 1 by 4 is a constant. 2s square is a constant. Differentiation of y is 1. Minus 6s is a constant. Differentiation of y square will be 2y. Okay, so this will be 1 by 4 into 2s square minus 12s. What is my y? Y is s by 3. So you can see clearly you have 2s square minus 4s square, which is obviously negative. Therefore, k is maxima. If k is maxima, a square is maxima. If a square is maxima, a is maxima when? When s is equal to 3y. K square is maxima means a square is maxima. If a square is maxima, a is maxima. We have already discussed this in the previous videos. Okay. Now, what is s? S is equal to 3y. But what is s from 1? From 1, my s is nothing but h plus y. So from this, h is equal to 2y. So what is y by h? Y by h is 1 by 2. Now you said find the angle between them. When I say them, it's angle between hypotenuse and the side that I have considered. So here, this is the angle that I want to talk about. Okay. Now, clearly from the diagram, it is nothing but cos theta. Cos theta is y by h. If cos theta is half, theta will be pi by 3. That is exactly what I needed to prove. Show that the angle between them is pi by 3. So I hope this is clear. It's a very, very important type of question. Okay, let's go to the next question. This is slightly difficult. So we'll just have a look at it. An isosceles triangle of vertical angle 2 theta is inscribed in a circle of radius a. Show that the area of the triangle is maximum when theta is pi by 6. Okay, so let's see. An isosceles triangle is inscribed in a circle. So first I will draw the circle because circle is going to be a constant. So circle is a constant. An isosceles triangle is inscribed. So I will take an isosceles triangle. So I prefer to choose this. And it is inscribed. An isosceles triangle is inscribed. Okay, so this is my isosceles triangle. Let me name it as A, and this is B, and this is C, and obviously these two are equal. Isosceles triangle. Okay, now let me drop an height. The height will be this. So this is the perpendicular drawn to the isosceles triangle. So if the area of the triangle has to be maximum, and if it is an isosceles triangle, then definitely that height must pass through the center. Okay, so it has to pass through the center. So I call the center as O. Correct? Then let's look at this. Let me choose another line. Or for that matter, I'll choose this line and copy it. So this is the radius. Okay. This is the radius, and I call that radius as A. And this is also A. Okay. So now, area of a triangle. What is area of a triangle formula? Area of a triangle formula is half base into height. What is my base? My base is BC and the height is AD. And the height is AD. You know, in an isosceles triangle, the perpendicular will bisect the sides, right? So clearly you can see BD equal to DC. Okay, and also my height AD is nothing but AO plus OD. AO plus OD. Or you can even say my BC will be 2 times BD. Okay? Because BD equal to DC. So I have created all this. Now he has said my vertical angle is 2 theta. This is 2 theta. If the vertical angle is 2 theta, by using the theorem from class 10th, angle at the center is twice the angle at any point on the remaining part of the circle. So this angle, the full angle will be 4 theta. The full angle will be 4 theta. But I am not interested in the full angle. Okay. Please remember, angle BOC is 4 theta. Since this is a bisector, it will also be an angle bisector. So angle BOD will be 2 theta. This will be 2 theta. The other side also will be 2 theta. So total angle is 4 theta. So angle at the center is double the angle for this. Since this is 2 theta, this has to be 4 theta. So each angle is 2 theta. Okay. Now look at triangle BOD. What is sine 2 theta? Sine 2 theta will be BD by A. Okay. Opposite by hypotenuse. Similarly, what is cos 2 theta? Cos 2 theta will be OD by A. Correct? So now let's go to this. What is BC? So BC will be 2 times BD. So 2 times A sine 2 theta. Correct? A sine 2 theta. Now what is OD? OD is nothing but A cos 2 theta. So take all this and put it here. Area is half. BC will be 2A sine 2 theta and AD will be A plus A cos 2 theta. Why? AD is AO plus OD. AO is A radius and OD is A cos 2 theta. So I have created all this. Now what do you do? I will take the A outside. So I get A square by 2. Okay. Now open the bracket. If you open the bracket, what do I get? It will be 2 sine 2 theta, 2 sine 2 theta plus 2 sine 2 theta cos 2 theta. I'm just opening the bracket. I keep half outside. A square 2 sine 2 theta plus 2 sine 2 theta cos 2 theta. So area will be A square by 2 into, this is 2 sine 2 theta and this will be sine 4 theta. I'm using sine 2A formula. Sine 2A formula. So now I'm going to differentiate. dA by d theta. You have to be very careful with this. A square by 2. Actually the difficulty is arriving till here. After that it's very easy. It is 4 cos 2 theta. By now I think you should know differentiation. Sine 2 theta is cos 2 theta. Differentiation of 2 theta is 2. 2 into 2 is 4. Plus cos 4 theta into 4. Now 4 is common. I'll take it out. So we get 2a square because 4 and 2 gets cancelled. So I'm left with cos 4 theta plus cos 2 theta. Now equate it to 0. dA by d theta is 0. When equate to 0, I get cos 4 theta equal to minus cos 2 theta. Okay, so which can be written as, I'll just close this. This is first part. This will be cos 4 theta equal to cos 180 minus theta. Correct? You know cos 180 minus theta is minus cos theta. So removing cos, I get 4 theta equal to pi minus 2 theta. Therefore 6 theta equal to pi. Therefore theta equal to pi by 6. That is what I wanted to prove. Prove that theta is pi by 6. That I have proved. Now second derivative. D square A by d theta square. Why do I do second derivative? To establish whether the area is maximum or not. Which is very obvious, which is 2a square into. Now what is differentiation of cos 2 theta? It is minus 4 sine 4 theta. And differentiation of cos 2 theta will be minus 2 sine 2 theta. Okay. Now this will be 2a square into minus 4 sine, this is 4 pi by 6. 4 pi by 6 is what? 4 pi by 6 will be 2 pi by 3. 2 pi by 3 is second quadrant, that is 120, so sine is positive. Minus 2 sine, it's pi by 3. So obviously this is negative because sine 2 pi by 3 is positive, sine pi by 3 is positive, so it is not going to have any impact with the negative sign. So it is negative. Therefore, area is maximum when theta is pi by 6. This is what I wanted to prove. Okay, very, very simple, but you have to be very careful while doing this problem because a lot of geometry is involved. Okay, let's go to this next very nice problem. It's a very simple question. So let's see how to go about this. It's more like a question from applied maths, but sometimes they ask for science also. A telephone company in a town has 500 subscribers on its list and it collects a fixed charge of rupees 300. They collect a fixed charge of rupees 300 per subscriber per year. The company proposes to increase the annual subscription and it is believed that for every increase of 1 rupee, one subscriber will discontinue. That means suppose if I increase the subscription by 2 subscribers will go out. Suppose if I increase the subscription by rupees 3 subscribers will go out. Suppose I increase the subscription by X, then X subscribers will go out. Okay. So what will be the increase? So find what increase will bring maximum profit. So I will say let X be the number of subscribers increased. So when I increase the number of subscribers by X, when I let X be the increase in subscription charge. Let rupees X be the increase in subscription charge. So if I increase the subscription charge by X, then the number of subscribers that will leave is X, because that is what he says. If one subscriber leaves, if I increase the amount by one subscriber will leave. If I increase the amount by two subscribers will leave. Suppose if I increase the amount by X subscribers will leave. So what is my revenue? My revenue is actually number of subscribers into amount per subscriber, correct? So what is the number of subscriber? Initially there were 500, okay? But since I am increasing the amount by X, the subscriber is going to decrease by X. So the number of subscribers will be 500 minus X. Then my subscription charge will be 300, but I am increasing it by X, so it will be 300 plus X. See, Number of subscribers is decreased by X, 500 minus X, because the amount is increased by X. So this is my total revenue. Okay. Now you can differentiate dr by dx. What is that? You can use product rule, which is 500 minus X, and differentiation of 300 plus X is 1, plus 300 plus X, and differentiation of 500 minus X is minus 1. So now you equate it to 0. This is my critical point. So when I equate it to 0, what do I get? 500 minus X minus 300 minus X equal to 0. So I get 2X equal to 200. So my X is going to be 100. So that means the increase will be 100. Okay, I have to increase rupees 100 to get maximum profit. How do I know maximum profit? I have to go for second derivative for the revenue. dr by dx. What is dr by dx? Once again, I have to differentiate this. 500 minus X is minus 1. And here, minus 300 minus X will be minus 1, less than 0. Therefore, my revenue is increased. R is maximum. When is it maximum? When X is equal to 100. So, what will be the increase? I have to increase the subscription charge by rupees 100 to get maximum revenue. So that is very important. It's a very, very simple question, but if you have to get the equations correct. Okay. Let's go to the next problem. This is also a very, very important type of question. All these are example questions. Find the area of the greatest rectangle that can be inscribed in an ellipse. In one of the videos, I have done area of the greatest isosceles triangle that can be inscribed in an ellipse. Here I am going to do area of the greatest rectangle that can be inscribed in an ellipse. Okay. So let's see how to do this. So first of all, let me draw an ellipse. Okay. So this is an ellipse. And what is inscribed inside? A rectangle is inscribed inside. Sorry. A rectangle is inscribed inside. A rectangle is inscribed. So I'm just trying to draw the diagram. Okay, I think it's reasonably okay. A rectangle is inscribed inside. Of course, I need to draw the major axis and minor axis. So this is the major x-axis. And this is the minor axis. This is the okay. So let me name the rectangle as A, B, C, and D. Area of the rectangles. So here what is said? Everything about the ellipse is a constant. Everything about the ellipse is a constant. But I have to maximize the area of the rectangle. So what is area of a rectangle? So I will take area of the rectangle as, okay, I will take the length as x and the breadth as y. Okay, so area of a rectangle will be x into y. Area of a rectangle is x into y. Now it has how many variables? It has two variables. I have to change it to a single variable. So I am going to make use of this. So what is y square by b square equal to 1 minus x square by a square? So what is y square equal to b square by a square into a square minus x square? So what is y equal to b by a into root of a square minus x square? Okay. Now take this and substitute here. So what is area? Area is x into, what is y? b by a into root of a square minus x square. Now this has how many variables? It has only one variable now. Now I have to differentiate. But remember, I have told you whenever there is a square root, you can get rid of it by squaring it and calling it as k. So what is k equal to? B square by a square. So in that way you can avoid the square root. A square minus x square. Now little bit patience, you open the bracket so that you can avoid product rule. So you get a square x square minus x power 4. Now you differentiate dk by dx, which is b square by a square, and differentiation of a square x square will be a square into differentiation of x square is 2x minus 4x cube. Now you equate it to 0. dk by dx equal to 0, and I equate it to 0. What do I get? I get 2a square x equal to 4x cube. So which can be simplified as a square equal to 2x square. Therefore x is equal to a by root 2. X is equal to a by root 2. Now what is d square k? Why do I do second derivative? To show whether the area is maximum or not. D square k by dx square, which is b square by a square into, this is 2a square, differentiation of x is 1 minus 12x square, which is because differentiation of 4x cube is 12x square. So b square by a square into 2a square minus 12 into, what is x square? A square by 2, which is 6. And you know 2a square minus 6a square is always negative. So k is maximum. When is it maximum? When x is a by root 2. If k is maximum, what is maximum? A square is maximum. If a square is maximum, a is maximum when x is a by root 2. But he wants me to find the maximum area. Now how do I find the maximum area? You can substitute here. So a equal to b by a x into root of a square minus x square. Okay. So which is b by a, x is what? A by root 2 into root of a square minus a square by 2. Now a and a cancels. So what are you left with? B by root 2, and if you take LCM you get a by root 2. So the answer is AB by 4. So this is the maximum area. I think it's right. Yeah, this is the maximum area. AB by 4 is the maximum area of the rectangle that can be inscribed in an ellipse. Okay, I hope that is clear. Now let's go to the last problem. I think this is, no, I have one more after this. So this is also a very nice problem. Just have a look at it. Find the dimensions of a rectangle that can be inscribed. Find the dimensions of a rectangle of perimeter 36, which will sweep out a volume as large as possible when revolved around one of its sides. So first let me take a rectangle. This is a rectangle. I'll take this as a rectangle. Okay. Now I'll take the side as x and the other side as y. So what is given to me? Perimeter. So 36 is equal to 2x plus 2y. So clearly you can see x plus y equal to 18. Call this as 1. X plus y equal to 18. Now he is asking me to generate a volume. How? By revolving around one of its sides. So I will revolve around the side x. So I am going to revolve it. It's like this. See, this is, if I say this is a rectangle. Okay, if I say this is a rectangle, I am going to revolve it around the side. When I revolve it, it will generate a cylinder. Can you see it? So I am going to create a, see, I am revolving around this. So I will get a cylinder. Correct? So I am revolving around y. Okay, when I revolve around y, I create a cylinder. So what is volume of the cylinder? Pi, radius will be x square, height will be y. Pi x square y, correct? It has two variables, change it to a single variable. Pi x square into what is y? 18 minus x. Very simple, isn't it? So v equal to pi into 18x square minus x cube. I open the bracket. Now I differentiate dv by dx. What is dv by dx? Pi into 36x minus 3x square. Now you equate it to 0. dv by dx equal to 0. When you equate it to 0, what do you get? You get 36x is equal to 3x square, or you get x is equal to 12. So the radius is 12 or the side is 12. Now what is d square v by dx square? D square v by dx square will be pi into differentiation of 36x will be 36 minus this will be 6x, which is pi into 36 minus 6 into what is x? X is 12, less than 0. Therefore v is maximum when x is 12. V is maximum when x is 12. You said find the dimensions, I need to find y also. So my y will be 18 minus 12, that is 6. So I have found the dimensions of the rectangle, okay, whose perimeter is 36, and it sweeps out a volume as large as the volume of the cylinder. Now let's go to the last problem for the day. This is the last problem. Very, very important type of question. Okay. Now listen, watch this question carefully or read it. An open box with a square base is to be made out of a given quantity of cardboard of area c square. So I have a cardboard whose area is c square. So it can be a rectangle, it can be a square, I don't know. Okay, so it's a cardboard that is given to you. And what is the area of the cardboard? C square. Now you are using a scissor and you are cutting in whatever way you want, and you are making an open box. What type of open box? An open box with a square base. So let me create the open box first. Okay. So this is the open box. So it has a square base. So this is x, this is also x, this is y. Why it is x and x? Because the base is a square. Okay. Now, what do you know? I am going to use this cardboard and make this box, and it is open at the top. So the surface area of the box should be equal to the area of the cardboard. So what is surface area of the box? First of all, the floor. The floor area will be x square, correct? It's because it's a square, x square. And there are 4 walls. Each wall area is xy. So the total area will be 4xy. Since it is open at the top, I am not using the cardboard there, so I don't have to consider the top. Now, I want to maximize the volume of the box. So what is volume of the box possible formula? X square y. Length into breadth into height. Now it has 2 variables, so I'm going to change it to a single variable. I will change this y, which is c square minus x square divided by 4x. This is from 1. My y will be c square minus x square by 4x. So now what do you do? Open the bracket. If you open the bracket, what do you get? You get c square x minus x cube. Now what is dv by dx? dv by dx will be 1 by 4 into c square minus 3x square. Now dv by dx equal to 0. You get c square equal to 3x square. Therefore I get c equal to root 3x. Very simple normal differentiation. Now, second derivative, d square v by dx square. What is d square v by dx square? 1 by 4. C square is a constant. Differentiation of constant is 0. So you get minus 6x, which is obviously negative. Therefore, v is maximum. When is it maximum? When c equal to root 3x. Now I want to find the maximum volume. So what is the maximum volume? Maximum volume will be, I will substitute here, x into c square minus x square divided by 4. So what is x? X is nothing but c by root 3, and x square will be c square by 3 divided by 4. So you get c by 4 root 3. If you take LCM, you get 2c square by 3. Now you can cancel this, it becomes 2. So the answer will be c cube by 6 root 3. That is exactly what I wanted to prove. Okay. I hope you have understood all this. I hope these videos are useful to you. I will be doing more problems and word problems in the subsequent classes. Kindly subscribe to my channel and click the bell icon to get notifications of video that I post. I hope these videos are useful to you. See you again in the next class. Have a lovely day.